Assalamu alaikum. How's everyone today? I hope you're all in the best of health. Today we're going to continue looking at the trains between Malaysia and Australia. Right, as usual we're going to look at Malaysia first. Train line just shows that it may stabilize, and if you look at Australia, since 2nd of April the daily cases in Australia has significantly reduced, so that's a good sign. This is a train line, it just shows that it's going downwards. It may confirm what we think. If you look at the daily cases comparison on a log chart, now it's obvious that it has been trending sideways, and if we may draw another line, it slows down a bit in terms of number of daily cases. Looking at the cumulative cases in Malaysia and Australia, Australia has tapered off at the top, if you can see here. It's showing the sign of slowing down a bit, and Malaysia has continued its journey on a straight line, a linear line. Looks like since the MCO imposed by Malaysia and the Australian restrictions on public gatherings has probably improved the situation a bit in Australia and Malaysia. I've changed the critical number of Malaysia to 16,200 beds because recently there's an announcement from the government that they've prepared more beds for the COVID patients. Right, now I'm going to talk about the SIR model. If you see these three images here, the one on the left is the current population which is susceptible to the disease, and some of this population is going to be infected, so you've got some of the cluster or the group that's actually infectious, and some of these infectious people have actually recovered. So you've got three compartments, and hence it's called SIR or SIR model. As you can see here from one of the papers modeling epidemics with differential equations, these epidemics can be actually modeled using ODE, ordinary differential equation. As you can see here, it's stated in this paper, June 21st, 2013. The well-known SIR models have been around for many years, and the equations is given as such. The rate of the disease being transferred from the susceptible group to the infectious group is actually negative alpha times S times I. That's S stands for susceptible group and I is infectious group. And the rate of the people being infected is actually di dt is equals to alpha times Si minus beta times I. And the rate of recovery dr dt is equals to beta times I. So this information is the one that I'm going to use in the modeling later on. I'm going to show you. Another important thing is the basic reproductive number. It is the average number of persons infected by one case in a totally susceptible population. Okay, so this number is also known as R naught, and is actually equals to the alpha over beta. Okay, if R naught is greater than 1, so there's going to be an epidemic. If it's less, there will not be any epidemic. Right, the SIR model in this paper by Salsky in 2012, Salsky mentioned that the equation SIR has actually been around since 1927, and it's been done by Kermack and McKendrick. In this model, you can see that susceptible is actually capable of becoming infected, infective is capable of causing infection, and recovered, which is removed from the population. There are some assumptions involved. I think I'm not going into great detail of these assumptions, but anyway, it's there. In coming up with this modeling, I've actually looked into several resources. One of them is actually ibmathsresources.com. I think it's been maintained by Ben Istor and Chris Johnson. Their paper is called Modeling the Spread of Coronavirus, which was published in January 28th this year, 2020. Another website I looked at was pandemsim.com, make your own SIR model. So this is one that I actually used to come up with this modeling for Malaysia. Another website that I looked at was Tim Church's Health Data Science blog. He's done some SIR model for Hubei province. Dr. Church has actually staff, University of New South Wales, I think in Australia, if I'm not mistaken. Right, and coming up with my own model, I've got to test my equations, whether it's correct or not. So I've used some information obtained as suggested by ibmathresources.com. I've got this information from a paper published in medRxiv. I've come across a British paper called Novel Coronavirus 2019, Early Estimation of Epidemiology. And I've actually used some of the information from them, and there's a paper published in medRxiv using this information here. In 14 days time, 4th of February 2020, our model predicts that the number of infected people in Wuhan to be greater than 190,000, within this range of 132,000 to 273,000. So if I can get it to be in 14 days with a figure between this 132 and 273,000 people, then I would say that the model is pretty accurate. Here it is. I just run through this table here. The one that's published on the right side here is actually obtained from IB Math guys. I'm using the figure of R0 equals to 2.14, as you can see here, and over a 14-day period. This information is actually from IB Math. The figure is around 129,000 people being affected, and this is what I've got here, 125,000. The margin of error is about 3%. So with that information, I can now start doing some simulation and have a look at the results, and this is what I've done. With R0 equals to 2.14, the total population affected is around 2 million. I then use the same equation to simulate for Malaysian condition, and I've actually used some interesting information. I used the data susceptible population of 70,000. Now, why did I use this? I'm going to have to explain why I use this figure. When I actually applied the same formula to the Malaysian condition, if you recall, the population of Malaysia is 32.3 million people. Now, if I apply the susceptible population of 32.3, the result is quite appalling. In other words, you're going to see here that about 15 million people is going to be infected in Malaysia. If you remember, JP Morgan has predicted that only 6,000 people is going to be affected at the peak in Malaysia sometime in April. So there must be a way of estimating that figure. What I did then, I started to dig how they actually estimate the number of susceptible population, and there's a big story behind it. So what I'm going to do now is to explain the figure of Malaysian susceptible population in my next video. Thank you for watching.